Alright, hello everyone. Welcome to the first video of this channel where we have a function called fx equals to 7 tan to the power 8x plus 7 tan to the power 6x minus 3 tan to the power 4x minus 3 tan squared x. Suppose we have two integral, one is I1 which is integral 0 to pi by 4 fx dx and another is I2 integral 0 to pi by 4 x times fx dx. Then what's gonna be the value of 7I1 plus 12 times I2? So while at a first look this problem, especially this expression of fx, may look intimidating to you, we will try to find out a common factor out of this complex looking expression. So let's start with the fx. From the first two terms, if I take 7 tan to the power 6x, I am gonna get 1 plus tan squared x. And similarly, from the third and fourth term combining together, if I take 3 times tan squared x, I'll again get 1 plus tan squared x. Now notice 1 plus tan squared x is a common term from these two terms. So let's take it as a common term, which is 1 plus tan squared x times 7 tan to the power 6x minus 3 tan squared x, right? Now, what's the value of 1 plus tan squared x? We all know this is sec squared x. So let's replace it with sec squared x, and we have the next term as is 7 tan to the power 6x minus 3 times tan squared x, which is the value of fx, right? Now let's calculate each of these integral individually. Now starting with I1, which is integral 0 to pi by 4 fx dx. 0 to pi by 4 fx dx, right? Now let's replace the value of fx here. Integral 0 to pi by 4 7 tan to the power 6x minus 3 tan squared x times sec squared x dx. Now think about how can we replace this variable sec squared x dx with another variable, which is substitute of variable, right? If you take u equals to tan x, and then if you take the derivative with respect to x, what you are gonna get? Du dx equals to sec squared x, which means du equals to sec squared x dx, right? So by taking u equals to tan x, I can replace this sec squared x dx with du. So I have 0 to pi by, now wait a moment, let's not put the limits here for the time being. So instead of sec squared x, I am gonna write du. Now what about these terms? So 7 tan to the power 6x is going to be 7 times, so u is tan x, right? So this is going to be 7 times u to the power 6. 7 times u to the power 6 minus 3 times u squared. Now, what about the limits of this integral? With respect to x, I have 0 to pi by 4. Now, what's going to be the limit with respect to u? So, if x equals to 0, what's the value of u? U is tan 0, which is 0, right? Now, if I replace, if I put x equals to pi by 4, my value of u is going to be tan pi by 4, which is 1. So instead of 0 pi by 4, with respect to u, my limits are going to be 0 to 1. Now this is just a simple calculation. You have 0 to 1, 7 u to the power 6 du minus, so I can take 7 outside, minus 3 times 0 to 1 u squared du, which is 7 times u to the power 7 by 7, u from 0 to 1, minus 3 times u cube by 3, u from 0 to 1, which is 7, 1 over 7 minus 0, minus 3, 1/3 minus 0. So 1 minus 1, which is 0. So the value of I1 is 0. What's the value of I2? All right. The value of I2 is again 0 to pi by 4 x fx dx. Now, for this one, I am gonna do integration by parts. U integral u dv is uv minus integral v du. Now, if I take u equals to x and dv equals to fx dx, right? So integral x times fx dx, if I replace the value of u and dv in this formula, I'll get x times integral of fx dx minus integral of integral fx dx, and du, this du is simply dx, right? All right, so and with the limit 0 to pi by 4 here, this will be 0 to pi by 4, and this will be 0 to pi by 4 again. All right, so we all know what's the value of this from I1, right? This is basically integral 0 to pi by 4 fx dx is simply I1. So this is x times I1, and this expression inside without the limit integral fx dx is not exactly I1, but this is simply this expression. Let me show you. Without the limit of 0, 1. So you will get 7 u to the power 7 by 7, right? So u to the power 7 minus u cube. Now if you again put u equals to tan x here, tan to the power 7x minus tan cube x. So without the limit 0 to pi by 4, just simple x fx dx integral is basically tan to the power 7x minus tan cube x. All right. Now I am going to put this value inside this integral. So tan to the power 7x minus tan cube x dx. Now wait, this value is already 0 because I1 is 0. We all know that. Now the second term, this one is simply 0 to pi by 4 tan cube x minus tan to the power 7x dx, right? So minus of this term is basically tan cube x minus tan to the power 7x dx. Now if I take tan cube x as a common term, 0 to pi by 4 tan cube x, I will get 1 minus tan to the power 4x dx. Now this is same as 0 to pi by 4 tan cube x 1 plus tan squared x times 1 minus tan squared x, right? So 1 minus a to the power 4 is 1 minus a squared, 1 plus a squared. I'm just using that formula. All right. Again, this is looking something similar to the prior calculation of I1. If I take uh, u equals to tan x, right? Du is sec squared x dx. And this term right here is simply sec squared x, right? So sec squared x dx is my du. Again, 0 to 1 after changing the limit with respect to u. This is going to be u cube. This is 1 minus u squared, and this is du. So you have 0 to 1 u cube minus 0 to 1 u to the power 5 du. Sorry, u cube du minus u to the power 5 du. Now this is just a simple calculation. U to the power 4 by 4 u from 0 to 1 minus u to the power 6 by 6 u from 0 to 1. So 1/4 minus 1/6, 2 over 24, 1 over 12. So I2 is basically, this term is 1 over 12 and I1 is 0. Now let's go back to the original term, the expression that we are trying to find the value of. So 7 times 0 plus 12 times 1 over 12. So the final value of this expression is going to be 1, and that's the answer. All right. Thanks everyone, and see you in the next video. Bye.